Hello people, how y'all doing? Today we are gonna be learning about parametric equations and polar coordinates. We're gonna start with a very simple. This lecture, to be honest, is probably one of the easiest lectures out of the whole midterm. And because you guys already know literally all of this, you guys literally know all of this. It might look like you don't know it, but once I'm gonna explain to you, you're gonna be like, oh, I already know all of this. The reason your teacher, okay, before we go to the prof and criticize the prof, we'll start with the lecture. So it says in high school, you study circles of radius r, and we find a certain relationship. We'll use these to convert between Cartesian and polar coordinates. And they gave you this table. And now the question is, what does this table mean? So I'm going to go to the side here, and I'm going to draw my perfect looking circle. Damn, that looks ugly. Alright, so perfect looking circle. Alright. Now, what does these equations mean? I'll tell you right now. We're going to go with number 3 first because it's the easiest. So if I give you this circle, well, first, before I get to the circle, let's say I give you, by the way, I found a new trick to make straight lines. Look at that. Right? If I give you this, right, and I tell you this is R, right? Let me go to like a thinner, finer point. I tell you this is R, then can you find me my X and my Y? Assuming I also give you theta, right? And even if I don't give you theta, all of you know that your Pythag theorem, which is r squared equals x squared plus y squared, right? We all know this. There's nothing new, right? And our second thing is if I give you r and I give you theta, can you find me y or x? We know that in order for you to find y, what you'll do is you'll do r sine theta. Sine is opposite over hypotenuse, right? Sine theta equals this. So if I take my hypotenuse and I put it up here, I'll get hypotenuse sine theta equals opposite. And so hypotenuse sine theta equals my y. And if I want to look up my cos, so you see cos theta equals my adjacent over my hypotenuse. And using the same thing, you get your hypotenuse cos theta will give you your adjacent. And so my r hypotenuse cos theta will give me my x. Now if I want to find my theta, if I want to find my theta, we know tan theta equals opposite over adjacent. And so if I get rid of tan, which if I do theta equals tan inverse of my opposite over adjacent, I'll get my angle. Your opposite and adjacent, your opposite in this case is your y, and your adjacent is your x. Make sense? So if you do tan y over x, you'll get theta. And so when you look at a circle, if I give you r, right? If I give you r, and I give you theta, which is counterclockwise from my x, then you should be able to give me my y and my x. That's a horrible looking x. But see, so it's not that complicated. You guys already know all of this. And so when we go here, that is covered. You guys know that x equals r cos, y equals r sine, tan equals y over x. Like, this is known. And I mean, it does say here recall, right? So fair enough. So it says, we know that Cartesian points are in the form of x and y. Well, polar points are in the form of r and theta. We're told how far we are from the origin at a given angle. And so you should plot the points 1 and 0. And assuming this is Cartesian, I'm assuming this is a polar point in terms of r and theta. And so you see here your first circle, this is your r equal 1, r equal 2, and r equal 3. It's just how far you are, really. And so when they're telling us 1, that's your 1. Our angle is 0. Right? And now they're going to tell us 2, so that's our 2. And they're saying pi over 6. Now, in this circle, they will tell you, I mean, they're numbered, but assuming you don't know where pi over 6, what you could do is you could say pi over 6 times 180 degrees over pi. My pi's cancel out, you'll get 180 over 6, right? And if I get my calculator and I do 180 divided by 6, I'll get 30. And so 30 pi over 6, what you can say is, well, these are 3, so we'll go here. This is my 2, right? Then I'm going to go up 30, and it's somewhere here, right? Right in the half on this line. And that is your 2, and we'll number it like this. So now you have -3, -3, and -3 is actually pretty simple. I'll show you a quick way to do it. So your -3 right here. So what we'll go is we'll go up. That's 1. That's 2. Now we're at 3. And it says here pi over 2, so we're in the right position. But since it's negative, you actually go the opposite direction. And that's where you are. And that is your pi over 3. Make sense? Hold on, I have my thing stuck for some reason. Okay? And so that is where your point is. That's all there is to it, really. If this is negative, you go the opposite way. You find it, then you go opposite. It's basically saying, you know, if I'm walking this way, 3r, and I give you -r, then you go here, and you're in the opposite direction. That is your -3r. It's your 180, right? And so what you can think about it is, you know, you go your pi over 2, 180. You add 180 to it. Okay? Polar coordinates of a point are this. Convert to Cartesian equation. And so what this is telling you is telling you r equals 3. And it's telling you your theta equals pi over 6. And we know we just said our theta is also 30 degrees. We converted it up here, right? Now, how do we convert to Cartesian equations, just in terms of x and y? And so you can draw your triangle. And then this is your r. And this is your 30 degrees. Now you can find me my y and my x. So see, my y is 3 sine theta, or in my case, 30 equals y, and 3 cos theta equals, well, cos 30 equals my x. Make sure, in the midterm, make sure your calculator is in degrees for 30, and it's in radians for pi over 6. Okay? So the Cartesian coordinates of point are this. And it's saying find the polar coordinates of this point. So now we're going to say, same thing. Use black. So if I make a straight line, right here, there you go. And what it's saying is my x is 1 and my y is 1. What is my r and what is my theta? So if we want to solve for our r, we can use our Pythag, right? R squared equals x squared plus y squared. And now we can say we can isolate for r equals the square root of 1 squared plus 1 squared. And what this will equal is the square root of 2. Now, when you square root, you get plus minus, right? But it says your r has to be bigger or equal to 0, so this has to be a positive. That's just as simple as that. Now your angle, right? Our angle here is your theta. If I want to find my theta, don't use your r, just in case you made a mistake here. Use your given variables. So we know we have y and we have x. Now if we do tan, which is opposite over adjacent, which is y over x, right? We have our y's and x. Now if I isolate tan inverse, and I'll get 1 over 1, which is 1, and tan inverse of 1 over 1 is 45. Now if you want to turn your 45 into radians, what you can do, I mean, if you can just put your calculator in radians and you do tan inverse of 1, that'll give it to you in your radians, which is pi over 4. And now you can see your limits between 0 and pi. Pi is actually 90. Oh, sorry, pi is 180. I don't know why I said 90. It's 180 and 0. Our answer is 45. So it goes between these intervals, which is, so this would be our answer. Okay, so now you can put in your Cartesian, which is our r, which is 2, comma, pi over 4. You guys know most of this stuff. Lifting, so now we're removing the restrictions up here, and we're seeing the point 101 has polar coordinates. Which ones apply? So the best way you could do this is, I'm better with radians. I don't know about you guys. So what I'm going to say is I'm going to do 9 pi over 4 times 180 over pi. The pi cancels out with this. I can just do 9 over 4 times 180. What I'll get is a 405. Alright, so now I'm going to draw a circle. Right, I have a middle point. 2, I'm going to root 2 away, which is fine. I'm going to keep that the same. And what I'm going to say is 405 minus 360. That'll leave me with 45. So what I'm going to say is I'm going to go 360 plus 45. And that's where I'm at now. Right? And if we look up here, we are same thing. 45 angle. Right? This is your 45 and this is your root 2. Right? And so when we look down here, we are in the same position, which is 45 and root 2. So this is correct. Now let's look at this. Converting this radians to degrees, 3 over 4 times 180, that's 135. So when we draw the circle, all right, we're going to draw the circle. And what the circle says is it says go in the negative 135. So we'll do 90 minus 135, or 135 minus 90. What we'll get is 45 here. Right? So what I did is I did 90 plus, so I have 135, whatever 135 is, I don't know, let's say, right? So what I said, well, first I know what my 90 is. What's the difference? I know 135 is here because it's past the 90, but it's not past the 180. So I know it's here. So what I'll do is you could also do 180 minus your 135, which will give you this. Or you can do 135 minus 90, so 135 minus 90, so I'm going to say minus this, will give me whatever this is, which is 45. But since we have negative, we go in the opposite direction, 45. And so that is the same. Right? Now here, we have 5 over 4 times 180. That is 225. So if I draw my circle, mind my horrible drawing. Okay, so where is 225? So 90, 180. I'm not even sure what 180 plus 90 is, so I'm going to just do that real quick. That's 270. So 270. Now if I do 270 minus 225, or 225 minus 180, both works, what I'll get is I'll get 45 again. So I have 90 here, and I got 45. But this is negative. So I'm in the opposite direction now. And I'm in the same position. So this is the same. All right. Now pi over 4 is actually 1 over 4 times 180, which is 45. Okay, so this would be 45, 45, but this is negative, so I'm actually here. So this is not the same. Okay, pretty simple. I would say this is 3 marks. The only difference they did here, using our equations that relate x and y, are we can define polar curves. All they said here is r equals a function now. That's all they said. Don't stress it. See, instead of r, they put a function that is in terms of theta. Nothing too special. Okay, so let's look at a few examples of curves defined in polar coordinates so that we have an idea of how to graph these. So r equals 5, so we just make a circle. And when it says r equals 5, this is 5. That is, and you know, it's obviously 5 all around. So that's that. And we have another example here of the angle. And so I draw my angle with my thing, right? Oh, I didn't know why hasn't it been doing this? Okay, and pi over 4 is 45. So we're gonna go 45. So that is 45. There you go. And obviously it goes both ways. Just like you know how we said 5 all around? This is 45 both ways. Because we're looking at the 45 angle from, right? And so that is what your 45 looks like. For more complicated functions, we could do a table of values or try to convert to Cartesians. Again, we're told how far we are from the origin at a given angle. How do we convert between polar to Cartesian? We just went over it right here. We've been converting. You see here we had x and y. You can convert in between. And so here they have to have some examples. So we're saying my r equals 5, right? So how can I find a Cartesian equation? They're not looking for an answer. Remember, they're saying equation. And so we know our equation from up here is r squared equals, so r squared equals x squared plus y squared. Sub it in. So 5 squared equals x squared plus y squared. And that will give us, there you go. That is your Cartesian equation now in terms of y and x. Okay. Convert tan to Cartesian equation. So again, here, what you can do, so the whole idea behind converting is you want to get to y and x. Doesn't matter how you get there, just get there. So if I have r equals 3 tan theta, what is the easiest way I can convert this to x and y? So I can do r squared like we did before up here. Technically, that would work, but we can just convert this into a Cartesian. So we can say, since we know our tan theta equals x over y over x, y over x, right? So now what I could just do is I could replace this. So now I have r equals 3 y over x. Now what I can do is r squared equals x squared plus y squared, right? So I already have my r. So now what I'll have is 3 y over x squared equals my x squared plus my y squared. And that is your other Cartesian equation. Now you could do all this and simplify. So I could make it 9 y squared over x squared equals my x squared plus my y squared, right? And you can bring it to the other side and isolate for either one, or you can just do it in another format. You could not even apply this. You could instead of applying this here, you could square root this whole thing. I mean, you don't really have to do any of this, but that's one way. No, so now the other part is converting our 5 secant theta to Cartesian. And the easiest way you could do this is the same way we were doing earlier, is r equals what can I do with secant? Can I put secant in terms of x and y? Can we? Let's see. So what is my secant? My secant is 1 over cos equals secant theta, right? Now what is my cos? So if I just write this, right? Now cos is actually your, if I can remember this correctly, it's your x over your r. But you see, you still have an r here. That doesn't really help you much. It gets you one way closer, but doesn't help you much. We also know r cos theta equals x. And so why don't we just multiply this, right? And so what I can say is this is x. There you go. That is a solution. So convert r sine to Cartesian equation. You could do the same thing here. Well, this actually is a division, so it's not the same thing. So what I'll do is, like we said here, a sine is my y over my r, right? Now, how do I get rid of my r? Well, this is here and this is here, so I could multiply. Now I'm one step closer because I got the r squared. So either want to get an r squared, or you want to get to a tan, or you want to get to like an r cos or an r sine. All those things, you can transfer them, right? And so what happens here, I get r squared equals x squared plus y squared. And now I can sub this in. Now everything is in terms, so I'm just going to square it with this instead. And now everything is in terms of x and y. And we have our Cartesian equation. So far, so good. I'm looking at this. I think I might have made a mistake. I think. Because if your r squared is this, oh yeah, this is the mistake I made. I forgot my square. So I do have a square here, and this is the same square here. So it's actually 8y equals x squared plus y squared. Because you have a square here. I forgot about it. And so this whole thing gets replaced here. And that's why you wouldn't get your square root. Okay. So here, given this, where x, know this. So here it's saying know this. Like, motherfucker, what am I supposed to know? There is nothing to know, bro. We did this in the last lecture, that your dy equals dx is your dy over dt all over dx over dt. And so if you memorize this from the last lecture, then it's the same thing here. It's just instead of t now, it's in terms of theta. That is the only difference. There's nothing to memorize. And it's saying, oh, where x, r, and y, like we know this. And even if you didn't know this on the test, you could basically figure it out. It's just going to cost you time. So it's better you understand it now. And here, your teacher gave 9 theta squared plus e7 theta. And so it says find dy over dx. You do the same thing you used to do when you had, what did you have? I'm trying to remember. What was it? T equals? But it's the same concept. So what you want to have is you want to get your dy over d theta, and you want to get your dx over your d theta. Okay, so the question is, how do you get your dy in terms of d theta, and how do you get your dx in terms of dx over d theta? And so we know one thing is that right here, so we know sine y equals r sine theta, right? And so r is given. Right? This is our r. And now we have sine theta. Right? Now, can I do dy over d theta here? Yes. This is y in terms of theta. And so how do I do this? You just derive this. And so if I want to derive this, actually I think I'm going to write it all into one at the same time. Because save space, because I don't have space here. So, and our x goes r cos theta, and this is given, right? There you go. And so now what we want to do is we want to derive this and apply it here. So let's derive this and write it out. My 9 theta 2, what this will turn out into, so this is my y, goes at the top, nice. So this turns out into, first you derive the first, you leave the last, this is the product rule. And so when we derive this, the 2 comes down, so you get 2 times 9, which is 18. And then your theta stays, your squared minus 1, so it goes away, plus. In the derivative, what this happens is you get e, 7 theta stays the same, times the derivative of your e, which will be 7, right? As the derivative of your 7 theta is just 7. I'm just going to put this at the front. But I forgot one thing, is you leave, so this is, since, what am I missing here? Oh, actually, oops. So this whole thing is your product. So what happens is we derive it, I'm going to derive this whole thing. That's my first derivative. Sign stays the same. This is a little bit late, so my brain is crunching. Plus, the first stays the same. Right? Times the derivative of your sine, which is cos theta. Now all this, so this is our dy over dx. Sorry, dy over d theta. Now all this over our x. So our x is basically the same. So I'm just going to rewrite this because it's the same thing. That's my first derivative. And then my second cos stays the same. Plus my first stays the same. And then I get the derivative of my, what do you call it? My cos, which is a negative sign. Right? And this is our dy over dx. So far, so good. Okay, so we have an exercise here, and it says given r cos squared theta plus e5 theta, find dy over dx. This is that. So let's do this to the side here. How can I do this? I think I'm gonna screenshot this, and I'm gonna bring it here so I can have enough space for it. There it is. All right. Right. So, since we have this same concept, we need our y. Plus, right, so that is our r sine theta, and then we have our x, right? Now we want to find our dy dx. In order to find our dy dx, we need our dy over d theta first. So let's derive this. We have cos squared. So first we got to get the derivative of the inside. So this is product rule. The derivative of the inside, this would be 2 cos theta. This is minus 1. And then the derivative of the times the derivative of the inside, which is sine, negative sign. Right? Plus my e to the 5t is just 5 e to the 5 theta. So as the derivative, and I'm going to leave cos the same or sine the same. So this is, we're doing y, so this is sine. Plus, this would be now my cos stays the same. right? And then we have cos theta, derivative of the second. And now if you do the top one, your bottom is basically the same, so I'm going to rewrite it. The only difference is your sine is cosine at the end. So you see here, instead of sine, we have cos plus and now we are deriving cos, which we get negative sine. Right? And now to rewrite this into dy dx terms, what we'll get is, so what I'm going to do is actually I'm just going to copy these and make my life easier. What we get is, actually, watch this. Watch this genius level. Copy this, paste it again. And this is our equation. And all you gotta do is just divide them together. And there you go. Alright guys, so for this part, I'm not really gonna go through it because you don't really need to understand this. The area of a polar region is given, this equation is given, and this is what we're gonna be using. So we're just gonna skip that top part and not waste your time. Okay, if you want, you can just search it up and you'll probably find a better example than I can give you. So find the area of a region that is bound by r1 plus cos, and this is your integral bounds. So it gives you here. So I'm going to go to the side, and what we have is our area. So if I have our area of an integral, is going to be my pi over 6 to 0, 1 over half. The equation I have squared. Okay, now my 1 over half comes outside, and I hope if you did decent on your integrals in your last midterm, because that was an integral midterm, then you should be able to cook this midterm too, because there's a lot of integrals. So you don't make all these petty mistakes, then you should be good. And if you're fast, you'll save yourself a lot of time. So I would suggest you guys practice this. And what we have here is 1 plus 2 cos theta plus cos squared theta. And if you don't know, okay, we have our d theta. Now you can integrate this, except this is the problem here. So if I fix this up, so you can take the integral of 1 and you can take the integral of 2 cos, but I'll just do it all at once. I'm trying to do this as fast as I can because it is pretty late. Okay, so now for this one, we have to use the half angle, which if I can remember it, it's what, 1 plus cos? Is that what it is? Not too sure, but I'm pretty sure that's the one. Even though I just said I'm not too sure. All right, and so now when I look at this, I can expand. When I expand this, what I'll get is 1 plus 2 cos theta plus 1 half plus 1 half cos theta 2. So I just expanded this, and what will happen is these two add, and what we'll get is 3 over 2 plus 1 over 2 cos 2 theta. Okay, now if I want to integrate this, I can integrate this up, on their own. So 1 over 2, my 3 over 2, the integral of that is just theta, plus the integral of this is 2 sine theta, plus the integral of this. You can't really integrate this, so what I'll have to do is a u sub, unless there's a better way, which I can't think of one right now. This will be, the derivative will be 2 d theta, and so my du will equal, right? And so when I sub this in, I'll get cos in terms of u, and then when I integrate that, just 1 over 2 sine u, which is 2 theta, right? But my d theta that I had here will get replaced with my du, but my du is over 2. So I have to multiply it in. So what happens is this becomes 4, right? And that is my integral from 0 to pi over 6. Now is the easy part. And so when you sub in 0 here, sine of 0 is 0, sine of 0 is 0, so this goes out, and this goes out. And obviously 1 over 2 goes out. So 0, you don't have to take the bound. But for your pi over 6, you do. All right? And that is your answer. Okay? Believe so. I'm seeing if I can find a quick answer, or should I put in the calculator? Okay, you know what? I'm gonna just leave this part for you guys to solve. It's just calculator part. All right? Now going down here, this one, it gets a little bit trickier. Oh, actually says that up here. Let's practice setting up a couple of trickier ones. The integration is just more trig integration. Nice. So find the area of one loop. So we're looking for this loop. And how can you find your theta to take the integral of? And so one way we can take the integral of theta is if you look at this loop, your r starts and it ends at the same point. Oh, wow. That is cool. There you go. So you see it starts and ends at the same point. And ends at 0. And so my r is 0. And so what I can say is 0 equals 2 cos 4 theta. And now I can solve for my theta. So what I can do, divide by 2, which will just stay at cos. Now I can cos inverse. I believe cos inverse of 0 is 1. Let me do that real quick. Cos inverse of 0 is pi over 2 actually. So I have pi over 2 equals 4 theta. Now the thing is, obviously as you guys know, there's multiple thetas, because obviously look at all these. She says we have one loop. So you see we have all these loops. And so what if she said, I want this loop? I mean, the area will be the same. But if you want to find the exactly, you can graph here. You see my cos goes this, and it oscillates every 180 degrees. Or every pi. And so if this is pi over 2, pi over 2 will happen again at pi over 2 plus another pi. And so if I do pi over 2 plus another pi, I'll get 3 pi over 2. So this is plus minus, because we have obviously plus and minus. And then we have 3 pi over 2. And if you add another pi, you'll get more and more and more. But obviously don't forget your 4 here. So if you divide this whole thing by 4, what you'll get is 3 pi over 8 and pi over 8 equals your theta. Hey guys, so I'm not sure if she taught you this, but there's a little trick for these type of questions. If you're confused with your bounds, you know, when you're looking for your integral from your alpha, your beta, these ask the type of questions. Actually, the angle you're looking for is between this and this. I'm not sure if she taught you this, but you see, these are the two angles we're looking for, and one is beta and one is alpha, and this is your angle, and it goes, you know, from some angle to some angle. How do you find this? What you can do is, the secret is this 4 in front of your equation. And so what you could do, since this is 90, right, what you can say is you can do 90 divided by 4 that we got from up here, and that would equal, if I look at it, that would equal 22.5, right? Now if you want to confirm if this is right, earlier we had pi. So see, we had pi over 8. So we could say is pi over 8 times 180. I'm going to convert it to degrees because this is in degrees. I use 90, right? Oops, I use 90. And this is over pi. These two cancel out. 1 over 8 times 180 is also 22.5. The other way you could think about this is you could say 90. You could say 90, which is pi over 2, divided by 4. And this would give you the same result, which is pi over 8. Okay, so this is one way you could get your answer. You could use some thinking and intuition. If, let's say, you had like this, right? I mean, you can tell that this is bound from 0 to 90, and these would be your bounds. And so that is a quick tip for you guys to find the bounds. All right, so now to set this up, it says just set it up. So we have our area equals the integral from bound 0 to my pi over 8, right? And 1 over 2, and the equation squared d theta. Now you can integrate this and do all the other stuff and find the exact, but I'm not going to waste your time with that. Now this is the other question, which is find the area contained inside this curve, but outside of R. So what is it saying? Find the area contained inside the curve, but outside R1. So see, this is our R1 outside. So we're looking for this. Now, to make your life easier, what you could do is you can find the area of a full circle and then minus it from this area, right? So now the question is, how can I find this area? So let me choose a different color. How can I find this area? So the way you can find this area is you can simply just use the equation and use the same way we've been doing before. So we'll say is R, so R equals 2 cos theta, and our R is 1. You see right here it says 1. So 1 equals, right? Now I can isolate. There you go. And now what I can do in my calculator, my fancy calculator, what I get is pi over 3. There you go. So now that I have my angle, what I can do is I can take the bounds. So if I do my integral, because I'm trying to find the area, right? So if I take my integral, pi over 3. So you see, if I did from 0, I did from 0 angle all the way to my pi over 3, what would happen is I would only get this area right here, but I want obviously both areas. And so what I could do is from this to negative pi over 3, and then the equation, which will be 2 cos theta squared d theta. Now remember how we said, so this will give us the area of this side. That's the area we're getting if this stops making my shit disappear. Oh my god. There you go. So that's the area it gives us. And now if we want to get the red area, if we minus this from a full circle, or actually it's probably the other way around so you don't get a negative number. Let me think. So this will give us the full circle, and then we're minusing a small circle from it. This might give you actually a negative number, but you should use your logic and get a positive number, set it up in a way that it gives you a positive number. So what we can do here is same thing. What do we need here? Negative pi over 3, 1 over 2. We want a full circle squared d theta, right? So, okay, I see. Yeah, I actually made a mistake with my thought. This equation will give you the full circle, and this equation will give you your R1, because you see R1, R1, and so this equation will give you that, and this equation will give you this. Yeah, because the area contained inside the curve R equals. So this says the area inside, so it gives you the R equals this of the full circle. Okay? It's too late at night right now, man. My brain is fried. Okay, so find the arc length of R. R equal. Oh, okay, so I'm assuming she gives you these details. So let me go to her lecture and see what she gave you guys. Okay, so what she gave is sine theta plus E5 theta pi over 6 pi over 3. And I mean, you guys should be able to do this really. It's just the bounds. So from this to this, how do you know which one goes at the bottom? It's the lower number. So this divides by 6, so that's a lower number. Right? Square root, your R is your sine. I mean, this, I'm telling you, this unit, or this lecture in specific, you guys should be acing. What is my dr over d theta? So your dr over your d theta is the integral of this, right? And so the integral of this is equal to the derivative of sine. Is it negative cos? No, it's positive, right? And then the derivative of this is 5e to the 5 theta. And so we plug that in. What? All squared. And there you go. And that is the end of your lecture. I hope I explained well. If you guys have any questions, write it in the comment below, and I'll make a specific video explaining just that.